Alright guys, here we go, Unit 8.1. I'm going to try to make these as brief as possible so that you're not sitting in front of your computer all day. But we need to get through kinetics and equilibrium, which is Unit 8. Alright, so we're going to start off this unit talking about something called collision theory. Collision theory is exactly what it sounds like. It's about collisions of particles. So particles that are hitting each other. In order for a reaction to take place at all, we have to have particles that hit each other. If you kept them in separate containers or you kept them in separate rooms, they would never hit each other, and therefore the reaction would never take place. There's a couple other things about collision theory that we have to keep in mind. We'll get to that in a second. But what I want you to know as we begin this journey talking about collision theory is that the more times these particles hit each other, the better chance of having a reaction take place. So take a look at this slide right here. I wrote it nice and big for you, and I will even highlight it right there. Collision theory states, in order for a reaction to take place, particles must collide. They have to hit each other. Okay? There are some other properties that we'll get to down here at the bottom, okay, where they have to collide with proper energy and proper orientation. But before we get there, we have to understand that in order for a reaction to take place, particles must collide. All right, once we get these particles colliding, how can we get them to collide more frequently? The more we get them to collide, the faster the reaction is going to take place. So let's take a look at ways that we can get the reaction to take place faster. We can get these collisions to happen more frequently. The first one, the dogs are going to bark now. The first one is by looking at the bond type. If you have an ionic compound, it's going to happen faster than if you have a covalent compound. Ionic bonds react more quickly than covalent bonds. The next one is pressure. And it only affects a gas. If I start squeezing a gas, let's draw this. I can actually move this. I haven't used this program in a while, so bear with me. Let me pause you. Okay, let's say you have a gas pen now, and it's in a container. Remember particle theory from when we first started back in September. These gas particles are really, really far apart from one another. If we put pressure on that gas, so we start pushing inward, all of these particles are going to get closer to each other. And just the mere fact that they're getting closer to each other because you're pushing on them means that they are going to hit each other more frequently. And the more frequently you hit, the better your chance of having a reaction. Okay, the next one is surface area. Let's say you have a sugar cube, and this one comes up on the Regents a lot, even though I don't know if you guys are taking the Regents this year, but we'll see. All right, so let's say you have a sugar cube. On the outside surfaces, here, the top, the bottom, the left, the right, the back, there's the back, right? There's 6 surfaces here. Let's say you have 6 surfaces. Now if I take that same amount of sugar, but I break it down into a bunch of other cubes, like this, okay? Now I have the surface area that's in here that can also hit other particles, right? So it's basically like taking this thing and breaking it down into 3 pieces. So if you look, this surface area in here is now open for collisions. So if I increase the surface area, then we're going to increase the number of collisions. Remember, that's all we're trying to do, increase the number of collisions. All right, the next one, let's see if I can erase this while I have you guys recording, is concentration. Concentration, obviously, the more stuff you have in a given area will increase the number of collisions. Just because, let's say I have 5 people in a football stadium, the chances of them hitting each other are very small. But if I have 50,000 people in a football stadium, then you're going to have a better chance of bumping into somebody. I'm going to skip catalyst for a second. We'll come back to that one. Let's do temperature. if I increase the temperature of a substance, what happens to the particles? They start to move faster. And the faster they move, the better chance they have of bumping into one another. Think of it as, let's see, if you start to increase the temperature of water on the stove, and then the water starts bubbling, see how it's moving so much faster? Now those water molecules are bumping into each other more frequently. It's not the greatest example, but hopefully you get the idea. And then finally, we have catalyst. A catalyst increases the rate of reaction because it lowers what we call the activation energy. You're going to see that when we talk about potential energy diagrams in a future video. But right now, what I need you to know is a catalyst takes particles and makes them collide with more frequency and with the proper energy and orientation. So we're going to get back to that in a second. So now everybody understands there's a couple of things that are happening here. All right, the bond type, the pressure, if it's a gas, the surface area, the concentration, the temperature, and the catalyst all make collisions happen, and they make them happen with the criteria that they need in order for the reaction to take place. Now that criteria is what we're going to talk about on the next slide. All right, remember I said in order for a reaction to take place, we need to have a collision, and we just talked about the 6 ways that we can make the collisions happen quicker. Well, not only do we need a collision, but we need the collision to happen with the proper energy and the proper orientation. In other words, if they just kind of nonchalantly bump each other, nothing's going to happen. They don't have enough energy, nothing's going to happen. The orientation, kind of think of it as a lock and a key. So let's say we have 2 particles, and we have the particles and they look like this. Oh, I have pink. Let's see. Okay, there's a particle and there's a particle. And this particle has like a little bump coming out, and the other particle has a space. If these 2 guys bump into each other, okay, I don't know how I just did that, but I did it. Okay, so let's say you have this particle and you have this particle. If they bump into each other and they bump into each other this way, okay, this little bump that I have here, let's see if I can find a pointer, right there, is not going into the space that it needs to go. So they are just going to bounce off of each other. But if they're flying around and they hit and they go in like that, now they're locked together. And so they have collided with the proper orientation. In other words, this little bump fits into the slot, just like a lock and a key. Okay? So not only do they have to bump each other with enough energy, they have to bump each other with the correct orientation. So let's recap. Collision theory states that collisions between particles can produce a reaction if, first of all, they need to collide, and both the spatial orientation and the energy of the colliding particles are conducive to a reaction. So they have to have both. So first they need to collide, then they have to hit it with the proper orientation and the proper energy. Reactants must collide in order for a reaction to take place. Reactions involving breaking existing bonds and forming new bonds. Okay? So that's collision theory.